talking about long division of polynomials. Basically, what it's going to be is a polynomial divided by a binomial. So this binomial is going to be in the form of ax plus b, and this could be in the form of anything. And I want to give you some basics first before we get into the actual process of what we do. One, it is a form of factoring. So instead of the factoring ways that we've done stuff in the past, and I'm sorry if this stuff gets crooked, my videos are awesome. It's a form of factoring because you can get an answer that's a product of two factors. Two, you can find zeros doing this. Three, it mimics numerical long division, which means that long division that you used way back in the day when you were first learning division, this mimics that process. It's not exactly the same, but it does mimic what you do. So figuring out what you got to multiply a number by, and then multiplying it and subtracting and bringing down stuff. It's the same type of things, but now we're dealing with x's. And now, your answer, and this is going to be kind of like a flow chart. You're either going to get no remainder, or you're going to get a remainder. If you get no remainder, one thing you know, the divisor is a factor. And the second thing is you can find zeros. And there's a couple other things, but we'll stick with that for right now. If you get no remainders. If you do get a remainder, you know what you divided by is not a factor. And then you know nothing about the zeros. So you don't know anything at all about the zeros in this case. So I'll give you a second to make sure you got this copied down. There are a couple other things that are going to be embedded inside the problems. I'm going to do 3 examples for you. One to kind of get you through, one that expands it a little bit. But once you get the pattern down of the steps that you have to take, if you take your time and you're writing everything out nice and neat, and this is one of those things where you want things in columns, you want stuff in its proper form, in its proper way, it is not the most difficult thing that you're ever going to do in the history of algebra. For some reason, students like to freak out over long division. Long division is not that bad. It really isn't. What you guys do is you don't put the effort into it to really just kind of understand it, and you don't correlate it back to things you've already done. Because it is something that we've already done. So, this is what something might look like. And I'll do one without a remainder to start with. You have x squared plus 7x plus 12, and it's going to be divided by x plus 3. So this is the case. Now, a couple things that you're concerned about. This polynomial that you're dividing something into, you have to take a look at the powers. What's this power? It's 2. It's a power of 2. What's the power on the x here? 1, 0. It goes 2, 1, 0, correct? That's what you want. You want it to go 2, 1, 0. Because if one of them is missing, we have to put in something as a placeholder in that spot. But we don't have to do that right now. We'll do that at a different problem. We're going to set up, and a couple students said, this is how we do things in Iraq. And I said, okay, let's try this. And I'll try it with you guys. And I like it. It's kind of neat. What they do is they create something that looks like this. It's a division symbol. You put the x plus 3 here. Now, the neat thing about this symbol is once we get to something called synthetic division, which we will do next week, synthetic division is a little bit more fun than this one. It has this same type of symbol in it. Ish. Kind of, sort of. But what we want to do is we want to put the x squared plus 7x plus 12, and we want it in columns. Because whenever we have something with an x squared in it, we're going to put it in that same column. Whenever we have something with an x in it, we're going to put it in the same column. Whenever we have something with a number in it, we're going to put it in the same column. Now, a couple things you need to focus on. We are always going to focus on the x of what we're dividing by, the binomial that we're dividing by. Whatever that first term is, that's what we're dividing by. And then we're going to focus on whatever is leading in the next one, whatever is in front of the next one. So here's what we do. We have to say, all right, what times x is going to be equal to x squared? Now, this x right here is this x right there. So what do we have to divide, or what do we have to multiply that x by to get to x squared? Okay, you got to multiply by x. So now x is what we're multiplying by, so that's our first answer that's going to go up top. Now you put it in the column of the x's. Now where's the x column? Right here in the middle. And now, so that was step 1. Step 2 is I'm going to take x, which is this x right here. I'm going to take that x, and I'm going to multiply it by x plus 3 and do a distributive property. Well, what's x times x?
X squared.
X squared. What's x times 3? 3x. And I'm going to write that underneath here. X squared plus 3x. And now, as I see some people are writing this stuff down, I don't want to get too far ahead of you. Think back to long division. Once you got that first number down here, what did we do? I heard it. No, not add. Subtract. So, the best thing to do is this. Put parentheses around it and subtract. Because if this ended up being like a negative 3x, and you subtract a negative 3, you're going to have to add it. So you want to make sure that the biggest trip up in this whole process are the signs when you're doing subtraction. So we want to make sure that the signs are all okay. That's why I put things in parentheses. Get used to putting things into groups and dealing with the groups, because that's going to help you out tremendously in keeping everything organized. So what's x squared minus x squared? 0. This is what we want. And I can't spell want. There we go. We want that 0 there because we basically are trying to eliminate that first term. So it's like an elimination game as well. If you treat it like a game, then all of a sudden it's not as hard. We're trying to eliminate it. And now I have 7x minus 3x. What? 7 minus 3? 4x. And what did we do with the next number? Bring it down. So we got plus 12. So now our next decision after we subtract this stuff is to say, all right, what am I going to multiply by that x that's going to equal 4x? Thank you, sir. It's a bonus question. You're going to multiply it by a 4. So the 4 goes up here. Now, then we're going to take 4 times x plus 3. Well, what's 4 times x? 4x. What's 4 times 3?
12.
Positive 12. And now we're going to make the group and we're going to subtract it. 4x minus 4x is 0. 12 minus 12 is 0. So, and here's the biggest difference. You know how we could go into decimals after this? We don't do that with this. Once we get to the end here, we stop. When we run out of terms, we stop. So I'm stopping here, and that 0 means there's no remainder. You know you're done when you get to that 12 and you bring the 12 down. And whether or not I got a number here or I got a 0 here, you're done. So you're always going to be done here. It just so happens that we ended up with a 0, which gave us no remainder. Now, what does it mean? What this means is x plus 3 times the stuff that we got in the top, x plus 4, that's equal to x squared plus 7x plus 12. And that's what it's always going to mean. So, in this case, if you get no remainder, you actually factored out everything. You're able to actually you factored instead of got something with a remainder in it. Yes, sir. Well, to turn that x into an x squared, I had to multiply it by an x. So that's represented by here. And so x times x is x squared. X times 3 is positive 3x. So I subtract it. And I got 4x. And then you got to bring down the 12. And then I say, all right, x needs to be a 4x. What do I have to do to x to get it to a 4x? Multiply by a 4. So 4 times x is 4x. 4 times 3 is 12. Well, that's this blue stuff here. Subtract those and I got a 0. So that's what you end up doing in that case. And since I had no remainder, I got this. I can find my zeros because now I know a 0 is going to be, what's going to make this one 0? What number is going to make x plus 3 0? What plus 3 is equal to 0? Negative 3. If you owe someone $3 and then you pay him $3, how much do you owe him? I want to owe you guys money because if I owe you $3, then I pay you $3, you're going to owe me $4. That's what you guys said back there, which is not anywhere close to right. So I like you guys. You guys can be my bookies any day. Negative 3 from here and a negative 4 from there. So we know where it hits the x-axis.
Is there like an easy way to do it? Like another way?
This is the easy way to do it. There's going to be another easier way. But don't look for the easy way. as a famous man once said, he was a professor. His name was Dumbledore. He said, now is the time to do things that are right, not what's easy. Sometimes the things that you have to do that are the correct way to do things are not the easiest thing on the planet to do. So what we do is, we do what's right. Because whenever you do what's right, you know you did the right thing. As soon as you start doing things that are easy, then all of a sudden you start getting into trouble.
I mean, wouldn't the easier way be still the same thing?
No.
Would it be
No easy way.
Isn't it also
There's a song out there that's called "There's No Easy Way Out." There is no easy way out.
there's always an easy way out.
All right, let's try another one. X minus 2. Now, the last one I set up, I set that one up because I knew that x plus 3 was a factor of x squared plus 7x plus 12, because I've been doing this for way too long in my life. But now I'm just going to I'll put an x squared there. Now, just make up some numbers. All right, plus 18x
Plus 8.
plus 2. No, this is just another way. This is just another problem. So, I have to key on these first two terms. You always start by keying on these first two terms, x and an x squared. So, what times x is going to get me to x squared? X. So, I'm going to put an x up there. Does that make sense? Because x times x is x squared. What's x times negative 2? Negative 2x. Now, I'm going to put parentheses around it, and I'm going to subtract. And the reason why I do this is, what's x squared minus x squared? 0. That's what we want. So that's good. 18 minus a negative 2. It's 18 plus 2 is 20x. And now what do we do with the 2? Bring it down. Yeehaw. Now, the next thing that I key on is this guy. So if you need a highlighter to make sure everything is highlighting the way that you want it to, and you want to make sure that you're keying on the right stuff, what do I have to do to x to get to 20x? Multiply it by 20. So I'm going to put a plus 20 right here. What's 20 times x? 20x. What's 20 times negative 2? Negative 40. Now, what do? We put parentheses, yes? And then we subtract. And I subtract so I make sure that all the negatives are in the right spot, but then if it's a negative and a negative, I make sure it's a positive. So it's all about keeping track of things and accounting for the proper things. So it's all about, honestly, algebra is 80% organization. And it's 20% following the rules. If you're organized, chances are you're going to do okay. Because the rest of it is just kind of logical. 20 minus 20 is? 0. Is that what we want? Yeah. Absolutely. So we did our business. We did what we needed to do. But now I got 2 minus a negative. If I subtract a negative, it's positive. And you can, all right, if we could do a little shorthand of a plus 40 here if we wanted to. What's 2 plus 40? 42. But here's the thing. We're done. This guy is a remainder. And the way that we write the remainder is we go up to the top here, we put a plus sign, and then I'm going to put 42, which is, let me move that down, the remainder, and then what do we divide by to begin with? What's the binomial we're dividing by?
X minus 2.
X minus 2. So technically, the answer to this is when you have x squared plus 18x plus 2 divided by x minus 2, you're going to get x plus 20 plus 42 divided by x minus 2. And that's your